Hello, everyone, and welcome to Module 1. Today we're going to talk about different web protocols, HTTP response codes, as well as web servers and generally how they function. So, the learning objectives by the end of this lecture, you should be able to understand the HTTP request/response cycle, identify major HTTP status code categories, understand and use curl to inspect requests and responses, install and test curl to inspect and request responses, as well as installing and testing Apache on Ubuntu and some of the common Apache features. Now, what is HTTP? HTTP is a hypertext transfer protocol, and it's something that we use every day. You use it when we use the internet, and it's the basis for client server communication models across the internet. Now, what does this mean by client server? Well, we, the client, often will request content from a website, also known as a web server, and it'll end up processing the request and then sending us back some content if we're able to get it, as well as a response code and all that content, as you can see here in the graphic. And this is all going to be through the browser, and we'll be able to use different URLs to contact different parts of the web server that's running, similar to how we would end up exploring our own files. Now, HTTP is also a stateless protocol, and this means that it doesn't retain session information between users. Now, there's several different versions of HTTP, and you may have seen this before. The very first one is HTTP 1.1, and this debuted in 1997 and is the basis for what modern HTTP is based off of. Now, it wasn't very secure and had some problems we'll discuss on the next slide, but one of the major ones is it wasn't secure. Everything was sent in plain text. So in 1999, HTTPS, which we're probably familiar with seeing in our browser a majority of sites, debuted in 1999. And while this helped alleviate some of the security issues, it didn't help alleviate all the issues that were experienced by HTTP. This is why there is the need for HTTP2 to be developed. And this actually came out in 2015. And a majority of the web traffic today is actually running on this version of HTTP. Now, there is shortcomings still with HTTP2 that were also experienced with HTTP 1.1. And HTTP3 tried to alleviate a lot of these. And this ended up actually implementing the QUIC protocol into HTTP. And this debuted in 2022. Now, to break this down a little bit better for us here, we have this diagram. And in this diagram, we can see the different layers for the TCP IP framework, if we're familiar with that from our networking class. Now, with this, HTTP is the application layer, as we can see in all these, and TCP is the protocol for transfer for the two of these. Now, one of the main problems experienced by HTTP 1.1 is that it wasn't truly multiplex, so you can send multiple messages at one time. Now, this is where we end up seeing HPAC and the stream in HTTP2 be implemented. And this tried to alleviate many of the performance issues that were experienced with HTTP 1.1. Now, you'll also see that TLS is baked into HTTP2, unlike HTTP 1.1, which you had to implement TLS 1.0 with HTTPS into this layer in order to have security. And this made it a lot more secure than its predecessor. But there are still some issues that were experienced with this protocol due to the nature of how TCP is actually built. Now, if you remember from your networking class, how does TCP function? Well, it functions with the use of the three-way handshake. Now, this three-way handshake ends up doing the SYN, SYNAC, ACK. We all remember this from networking class. Well, if you end up having errors with HTTP, it tries to recommunicate it. And with HTTP 2, if you end up having too many errors at once, it has this issue called the head of line blocking issue. And this makes it so that all concurrent streams actually end up stopping. And this ends up making it so that it has to resend the error and then restart all the streams. And that makes it really bad on performance, especially in IoT environments, which are widely deployed today. Now, with this in mind, there was a need for a new type of HTTP, and this is where HTTP 3 came in. Now, you can see with this that it has a similar queue package stream, much like HTTP 2, but there's two major differences. One is that QUIC is actually implemented here into this protocol, in that it's actually UDP based versus TCP based. Now, with QUIC, it implements TLS 1.3 by default, and this removes all the overhead that you have with the application layer for security. Makes it a lot more efficient. Also, by using UDP, you now only have one single hop, or you end up having your round trip time go from 3 hops with a three-way handshake to a single one. And this is all established when you connect using HTTP3 through the application layer and it's managed there. And this is really beneficial because if there's an error, it doesn't stop all the other lines of communication that are going on with applications. And this is really beneficial for our IoT environments, which are getting widely deployed today with all the different smart objects that we have. Now, HTTP has a request structure that you'll end up seeing in a few slides later on, but the main methods are get, post, put, and delete, which we'll talk about on the next slide, as well as request target or URL that it's going to contain, the headers, and the optional body that sometimes is there. Now, this is a big slide here, but we'll try to go through the highlights. So with get, what you're trying to do is actually retrieve data from the server. And there's this idea of independency, which means that it doesn't change the state of the server. And with the get request, just requesting data, it doesn't do this. Now, post sends data to the server in a create process, and it's also not independent because it doesn't duplicate any actions. An example of this will be submitting a form or creating a new user. So also similar, doesn't change the state. Now, the put actually replaces an entire resource. And with this, we have an independent result every time because it ends up existing a record. Now, we also have the patch option, which partially updates an existing resource, and this is not impotent. And this might be an example of modifying only one field of a record. Delete also is different than patch. It removes a resource from the server versus updating it. And this is impotent. Now with head, it's the same as get, but returns the headers only and is used for checking the availability of metadata without downloading it. And then finally, we have the options, which returns supported methods and server capabilities to the user. And these are the major ones that you end up seeing. Now, we're going to mainly be working with GET requests a lot of times, and you might experience out in your line of work that you might work with some other different types of requests. But think a lot of these are going to be GET requests because we're using curl. And that will end up leading to our next topic after we go over response structure. So we talked about what's in there, but typically it's going to have a status line when we end up interacting. In this case, it will tell us the version of HTTP, as well as the status code, and if it's allowed or not. It will have the response headers, as well as the response body. Now, something to note is there's different response codes. You may have had an issue before where you try to go to a website and it's not accessible. And while this is annoying, we might have seen a 404 error at that point. We might have also seen a 403 before. You accidentally typed the wrong thing in and you get a forbidden error. Now, these are different errors, but they fall in different categories. 100 level errors, or 1XX, are informational. They're going to tell you a bit about what's going on. 200 level are going to be for success. 300 level are for redirects, which we've seen this if you go to one website and it sends you to another. Or 400 are going to be client level errors, which are your errors, you experience them. And 500 level errors are going to be server errors or issues with the web server itself. Now, this is a big table here, and I'm not going to go through all these, but some of the main ones that you'll run into are 200, okay. You might also see 201, which is created. Now, at the 300 level, you might see 301, which is moved permanently. or you might end up having a 302 temporary direct. Now, with 400, often the most popular one that you're going to see is 404, not found, or 403, forbidden. And with 500, the most often that you're going to see is 500, which is a server error, or 502 bad gateway, or even 503, which is a service is unavailable. Now, I mentioned curl. Curl is a feature or an executable that we're going to be running in the command line a bunch in this course. If you haven't used it already, it helps you pull information from with or using the command line and expecting HTTP content through the network. And if it's not installed on your VM, you can install it using sudo apt install curl and then just verify it with curl dash dash version, and it should tell you which version of curl you're running. And curl is a way to use command line to capture HTTP content from web servers that we'll be commonly using, like I said, for the rest of the course. Now, this is an example of curl. One type of curl is just a basic curl. You just pull a web page. This is going to pull basic information. Now, if we end up using curl-l, it'll end up just giving us some of the headers information. Think of it more like a long listing way if you're familiar with stuff with Linux. Then if we end up using the -v option, which we see here in this command, it's actually going to give you the full response, which a lot of time if we're trying to figure out an issue of what's going on, we're going to want that full request. And I regularly recommend that you use all of these throughout the rest of the course to debug stuff and check different ways. You might not always need the full curl request if you just want to get a little short output, but sometimes it's good to see what exactly is going on. Now, this brings us to what is a web server? We kind of talked about the process of how it works, but we need to talk about what exactly is a web server, because when we're using client server approach, we end up needing to know what are the servers and what are the functions. And there's a few different ones that you're probably familiar with, but the most common one is probably a web server. And it's a type of server that ends up hosting an application, whether it ends up running in a VM or on the bare machine itself. And it typically is going to serve content using HTTP through browsers. And as I said, they're the backbone of the modern internet infrastructure. And all the content that you interact with is served from a server. Every website you go to, you're interacting with a web server in some way, whether it be through a traditional web server running on a large scale farm or a data center that someone has, or if it's just a small one running in a container. Now, servers also are commonly used to manage and run games, and these are typically a similar way. If you're playing a video game, you'll end up accessing it through the network, and you'll be able to load in the game and then play with your friends. So it's another common function of that's similar to web servers, where a lot of times though you have a custom browser provided through the game engine or the game application itself. Now, this leads us to need to know what are the top web servers. Since this class primarily focuses on web servers, what are the top web servers and why should we care about them? Well, the two top web servers are Nginx and Apache. Another common one is IIS offered by Microsoft or Lightspeed. And there's many other smaller competitors. I recommend checking out this link I have below that shows you the ranking. Currently, Nginx is in the lead by about 1% versus Apache. And Apache used to be the king of everything. Although Apache does not support HTTP 3, which a lot of applications are trying to move to because it also has post-quantum encryption protection. So you'll end up seeing over time, unless they include that module, they'll end up falling even further behind. But for right now, they're neck and neck with Nginx still, because a lot of different organizations will run what's called a LAMP stack, where the operating system is Linux, you're running Apache as your web server, you're ending up running PHP as a language, which is a P in it, and you end up running MySQL for the database or the storage for your website. Now, in order to install Apache on Ubuntu, super simple, and this is why a lot of people use it, because open source servers, you don't have to pay for a license, and the same with Apache. It's open source, you don't have to pay for a license to use it, which is nice. And what we always want to do before we end up installing anything is making sure our system's up to date. So the sudo apt update command, always run it beforehand. Then after that, you sudo apt install Apache 2-y. The -y flag just goes through the yes, I want to install this option that it will throw if you don't. And then you do systemctl status Apache 2 to check if it's actually running. If it isn't, you can end up doing system control status Apache 2, or you can end up doing restart Apache 2 using the system control commands. And we access it via our browser using the curl command. Now, the default web root directory for our web server where everything is stored is var/www/html. And this works just like a normal directory does in a computer. You can serve anything that's inside these directories. And you can change the root. But typically, your root's going to be the index.html. And you can change that in the Apache config file if it's not that. Now, we already talked about this a little bit, but you're going to be testing some codes or SAS codes in the lab. One of the ones that you're going to get is 200 OK. Another is a 404 not found. And another is a 403 forbidden. And then finally, you're going to get a 500 error for the lab. So just going over what you will experience as we kind of talked about all of that. Now, the last thing we need to talk about is that htaccess and other module parts of Apache. So what is .htaccess? Well, it's a directory level configuration file that's used by Apache to allow different runtime configuration changes without having to restart the server. And some of the key functions of .htaccess is access control. You can restrict files or directories or IPs. You can also do different rewrite or redirect rules, which are crucial if maybe your one web page is changing. You might want to redirect it. You also can have authentication where you can have passwords in here. So you can actually have username and passwords, which is very common for websites. Then you also have the base authentication, or you have the custom error handling that you can also put in here. So define custom errors based on what the pages you want it to do, as well as the content types with MIME types and headers. And then finally, security hardening. You can disable directory listings, block file types, and limit methods for how you can access these. And this is an example of a configuration file showing this. So we can see with the rewrite engine on, it will actually rewrite different pages. You have to turn this on. We can force HTTPS, which is a common practice. We want to have secure communications because HTTP uses plain text. We don't want that. It's not very secure for the internet. So we can actually specify what we want the conditions to do. And you'll get a little bit more through these in the lab as you work with some of these. But you can see that we specify we want the host and the request URI to use HTTPS. We can also disable directories and list indexes of directories we want disabled. We can also password protect this directory so that we have a password file that we create here, as you can see with the .ht password, and require a valid username and passwords. So pretty basic stuff there. We can also list the document errors for error pages. So if there's an error, we can say that perhaps if it's a 403 error, we're going to go to the 403.html error page because we don't want it displaying a blank web page for the user. And as I mentioned, for security, since that's a core feature we want, we can also go ahead and block certain IP addresses. Because the IP addresses can be listed here, we can end up denying all of them, or we can try to set an entire subnet range. And we can also block access to certain file types based on what we want to end up setting the methods as we can see here. And this gets us to one of the other key directives that you'll see in the key configuration file for Apache, which is the apache2.conf file. Now, one of the reasons why it matters that we end up having the allow override directive is without enabling it, we can't use our .htaccess file. And if it is used, then it will process our htaccess. If it's not enabled, it won't process it. And a common cause of this is one of the common causes of redirects not working, authorization rules being ignored, and security settings failing silently. Now, the three main values that you can set it as none, which disables .ht access. You can have all, which allows all directives, and then you can have selective, where you can end up specifying groups or behaviors. And you can see here an example of how that directive looks in the configuration file. Now, before you mess with the configuration file, it's a good idea to make a backup just in case you have any issues that arise and you're unable to troubleshoot them. You don't want to end up having your web server go down. It's better to work with a copy. And then, if you have to, you can re implement the old working copy of the configuration file. So, we went over a lot, but this leads us to our review questions for today. So, what are the differences between get and post? I'll give you a few seconds. Go ahead and pause, think. So, the main differences is get retrieves content, whereas post actually submits data to the web server. So, the second question, why is HTTP considered stateless? So it's considered stateless because it doesn't retain session information between users, and each time you connect, it's a new session. Now, our third question, what does a 404 error indicate, if we remember from that table that we had? So 404 indicates that it is a missing resource and it can't be found, if we remember. And then finally, how can curl be used to debug web servers? So curl, if we remember, can be used to debug the web server by seeing actually what the raw HTTP content looks like by pulling it through the command line. So that about summarizes what we went through today. We ended up talking about different HTTP states as well as how it functions in different versions of HTTP. And we talked about the different kinds of web servers as well as what the top web servers were and how they function using the client server architecture. So that's our lecture for today. If you have any questions, feel free to reach out to me, and I'll see you all in the lab.